Hi. A couple of days ago, somebody asked me about um, the problem of comparing two poker hands to write a Python program which would compare two 5 card poker hands and determine which one was the winner. And using a table like this. And so it sounds kind of simple, a little ish, but also a lot of details and kind of maybe finicky and tricky. So I wanted to step through an approach I took to solving this problem, and maybe you'll find it interesting and just a way that you might solve this or similar problems like that. So, I want to show, I did a little quick search. Someone asked about writing that there's one in Stack Overflow, and there's this insanely cryptic solution here in Python. I barely understand what's going on with this solution, but let's try to write a solution that's just a little bit more readable and something that you could actually derive yourself in a more straightforward manner. So, looking at the kind of available kinds of poker hands, this is a ranking of all the different types of hands you could have, from straight flushes, 4 of a kind, full house, flush, straight, 3 of a kind, 2 pair, a pair, or just you don't have anything else but just whatever your high card is. So what I will do is let's work out an algorithm that will categorize poker hands into each of these groups and figure out which one of them it lies in, and then you can compare two things, and if they're not in this, if they're not in the same group, you know which one is stronger hand than the other. I'm not going to handle the case of two hands that are in the same group that are to see which one is stronger than the other, because that they're like 3 threes is better than 3 twos, but that could be an exercise to improve this later. So one way to do this, so in Python, you have this thing called a Jupyter Notebook, and Google has a product called collab.research.google.com, and it'll host a Google Notebook for you, so you don't even have to install any software. The cool thing about this is you can write statements in Python. If I just hit Shift Enter, they actually evaluate in Python. And so that's a way that you can execute a bunch of Python code interactively. It'll save it in your Google Drive. So let's use that. And I worked this out in advance, so I'm going to be using some notes that I took before. But this is the order in which you kind of explore this problem, writing code in Python and exploring the dimension of the problem and kind of work our way toward a solution. So since there's a lot of details to figure out. So first of all, we have to have the representation of our cards. And I think an easy way to do that would be having an array of strings, and where each string is a card. And I'm going to put, like, the first character will be the value of the card, and the last character will be the suit. So let me give you some examples here. Let's see, I have some test hands here. Let's see if I can just paste that in here like this. Does that work? Test hands. Yeah, there they are. So these are several different poker hands in increasing strength. Like the first one really is just ace high. Ace of clubs, 5 of clubs, 10 of clubs, 7 of clubs, 3 ace spades, etc. And the next one has a single pair in it. It's the twos. There's a 2 of club and a 2 of diamonds. So I just came up with these off the top of my head as some samples. So that's just to give us some test cases to work with. So first of all, you need a little bit of code to decode this format to give us things like the value of a card or the suit of a card. So we'll start off with a function that takes a card, and to get the suit of the card, we're going to just get we'll just treat it as the last letter of the card itself. And in Python, you can do it like that. And so we could do things like suit of ace of clubs. That's a club. The suit of 10 of diamonds is a diamond. So there we go. So now we have a suit. And then we have another function that's for the value of a card. So to get the value out of the card, we need to kind of parse that first part of that that symbol. So just say if the first letter is an A, then we're going to return 14. Now, I'm just going to return a value of every card. I chose 14 for an ace because ace is considered a higher value in most cases. It could also be a 1, but for now we'll just say like the value of an ace is 14. And so we'll say if the card is a jack, then we're going to return an 11. And if the card, oops, sorry, fumble fingers, okay. If it's a queen, it's a 12. And I could maybe have done this with like a lookup table instead and have a little bit less code. But I'm not really out for efficiency at this point. We're just out to have something that's correct and it's easy to understand. So if it's not any of these, then I'm just going to parse the first part as a number. And there's no error handling here too. So in Python, you can say everything but the last character of a string would be something like this. And let's do that. So let's try some of these ones that we had up here. What's the value of ace of clubs? Value of ace of clubs. 14. That's good. What's the value of 10 of diamonds? 10. Okay. So looks like it works ish. We might find other bugs later, but that's kind of a good test case. So, I know some of our hands, we're going to have to determine whether it's a flush or not. Flushes are special cases, and that seems like a pretty easy things to test for. So why don't we write a function just that says, are these 5 cards a flush? So if I have an array of cards, and to do this, I want to detect if every card has the same suit. And so in other words, like if all the last 4 cards are the same suit as the first card. So I could say if all of, and I'm going to use a list comprehension in Python, if the suit of the card equals the suit of the first card, for card in cards, and we go one to the next to the last, and I think that's it. So we can try this on all of our test hands at once. I can say, what is flush of hand for a hand in test hands? There we go. Let's see, is that correct? Our first one, is it a flush? No, it's not. That's wrong. So I made a mistake here. I wanted to include, I want this to be all but the first card. There we go. Okay. So if all but the first card is equal in suit to the first card, then we have a flush. And so it's the last one and the fourth from the last one. So we look back at here. Yeah, see, this one's all spades and this one is all clubs. So yeah, that looks good. So great. We've got one of our a set of things here already figured out. Okay, so now it gets a little harder. You think like, how would I kind of evaluate these other things? I'm gonna have to like order them or count the ones that are similar and things like that. So I thought of maybe sorting. You could sort all the cards in value order, and then you have a list of just numbers. You could have just a list of value numbers, and then you could write some code which would, once they're sorted, look for runs. What are the longest runs of things like that. Look for or straights or longest run of the same number, and but I decided, it might be useful to have a different representation, and I was thinking of like a distribution map, something that shows me, there's a 1-bit every place there, or there's a count for each of the values. So for all 13 values, or actually there are kind of 14 values, because ace could be low or ace could be high. For all 14 values, how many cards are there of each of those values? And we could just create a Python dictionary that would represent that. So let's see if we can create that. So I'm going to call it the hand distribution. So hand distribution of cards. How do I do that? Well, first let's initialize it all to 0, and you can use this dictionary comprehension. I'm going to set I to 0 for I in range 1 to 14, which is Python does it 1 greater than that. So there's an empty distribution. And one thing I can show you, what does that look like? We'll take a look at that. Let's create a new cell here. I'm going to type that in there so you can look at it. Yeah, so there it is, just a dictionary of zeros. So that's what that is. Let's continue with this function. So I'm going to look at each of the cards here, and we're going to increase the dictionary value for whatever the value of that card is, and we're going to add 1 to it. So that's easy. And now, because we treated ace as 14, we also want to say it's a 1, whatever if we have an aces, we want to add the value of 1 in our distribution too. So I'm going to say the distribution of the ace low value is exactly equal to what we have the ace high value here. So, and then we'll return the distribution. Okay, so there we go. We have a bunch of distributions. Let's go ahead and reuse this cell and use our test cases again. We can take a look at all these hand distributions of a hand for hand in test hands, and we'll look at all of them. So here they all are. So here you can see our first code. We have an ace, a 3, a 5, a 7, a 10, and then and the other representative of an ace. So take a look at that. Ace, 3, 5, 7, 10. So notice how, like, no matter what order these cards are in, we're going to get the same distribution. So that's a nice property of this kind of data format. Puts it into a format, where we can see runs of cards. We can see here's a pair, obviously, because there are 2 2s. We can see things like here's 2 pair. This one has 3 of a kind, and I think you can start to see some straights with this run of characters here. I think one of 1s here is a straight, and so it's kind of a useful way of looking at these. So I'm not sure what this hand is here. I think this has gotten kind of a big. This cell got kind of big. Let's see if I can scroll all the way to the bottom. There we go. Yeah, this is like I think we had a royal flush here, where it's a straight here. Now you can't see whether it's a flush or not here. These are just the values. So let's think about our straight, like the evaluator for figuring out if we have a straight. And for straights, we're going to be looking for something that is, you know, five single things in a row, and then ultimately we might want to compare like which straights are higher. So what I would do is write a function that returns what if it's a straight, return the high card of value of this straight, and if it's not a straight, just return none. So let's try that. So straight high card of cards. So again, first off, let's get the hand distribution of those cards. Oops, didn't mean to finish that. And now let's go through all the values in the range of possible beginning values of straight. So we can begin at from an ace up through 10. So this will be a range of from 1 to 10. Okay, and then if all of those cards in our distribution of the value and we're gonna look at five different cards. We'll have another index plus k. So if all the cards in the distribution from the card value to value plus k, if all of those are equal to 1 for k in the range of 0 to 4, yeah, I think this is a list comprehension here. Should put that there, and then we're going to return value plus 4. So the highest value card in the straight is going to be the beginning value when they're in ascending order, plus 4, and otherwise return none. So that is it. And I got a syntax error because I think I have this wrong here. Extra parenthesis. Okay. Again, let's do that other test case. Let's see, straight high card of hand for hand in test hands. And we should have a 14 here because it is that is a straight flush also, and this is the wrong value. So let's see, what did I do wrong? Oh, I just put a number 5 here. That should be k. Value of k for k range 5. Yeah, okay, that looks better. Let's see how that does. Nope. Okay, I think I see my mistake here. This looks like it's indented wrong. That's not supposed to be in the for loop. So if this for loop doesn't return anything, then we return none at the end. I was returning none all the time. There we go. So we have a 7 high straight and an ace high straight. So if we look back at our test cases, this one I think is the 7 high straight, 3, 4, 5, 6, 7. And then this one here is the ace high straight. All right. So what do we have next? So we got straights and flushes figured out. I think a good helper function would be to be able to say if we want to look for if there are cards of a given number of a given count, like we're going to look for, are there any 3 of a kinds? Are there any 2 of a kinds? And return the value of that card. Then I think that would be a nice helper function for this. So let's take a look at that. We'll say card count of cards, and we're going to say we want one particular number for the number of cards that are there, And again, we'll start with the distribution. That's a good helper function for us. We'll get the distribution of the cards. And then we'll just look for all the cards in the range from 2 to, we don't want to count the ace twice. We'll use only the high value of the ace. So we'll start at 2. We'll ignore the low value of the ace in the distribution. We'll go up to the high value. And then I'll say if the distribution of the value equals the number, so we found a 2 or 3 or whatever we might be looking for, and we're going to return the value of that card. And then if we don't find anything, we're going to return none. Okay, so let's see if that will work for us. Why don't we could try our test cases again. Why don't we look for 3 of a kind and say, what's the card count for a hand with 3 of a kind in it, for a hand in test hands. Okay, so it found the number 4. There's a 3 of a kind of 4s, and there's a 3 of a kind of 8s. Let's take a look at that code again. Let's see if did that work right. Here's a 3 of a kind of 4s. That looks right. And down here is a 3 of a kind of 8s. Okay, looks good. Similarly, we can get 2 of a kind and stuff like that. But if I think about it, we're looking at our table here. That'll work great for 4 of a kind. We can find a 3 of a kind and a 2 of a kind here. But what if we have two of a kinds? We're looking for both of them, and our function would only find like the first one in that list. So let's just make a little adjustment to this thing and say, sometimes we'll want to exclude a particular card that we've already found a pair. We want to exclude that. I'll just call this but. We won't. But if we find something that's not a particular number, we want to exclude that one. So if we give a value for that, we want to exclude that value. So if the value is our but value, we'll just continue this loop, and we'll just not try to look for that anymore. So so I could look for 2 of a kinds here. I can see I have let's see, I think one of these has two of a kinds in it. I think this one here is 2 pair. It has 2s and 3s in that one. And so when we tried it here, we looked for a card count that had 2s, and it has 2s there. But what if we want to exclude the 2s? There we go. Now I found that one had 3s, a pair of 3s in it too. Great. Okay, so now we have a very handy function. I think we are ready to write our function that goes through this whole list and tests for all of the different ways that it could be any of these ranks. We'll start at the highest rank one and work our way down. And so we'll say which card rank, which hand rank for a set of cards. So the very top one is a straight flush. So if the straight high, we called it straight high card. We're not really using that card, but we'll just say if it's not none, so there are no card that it found for a straight. So that means that there is a straight. And if it's a flush, we have that will return 8. So we're going to divide these up into 8 groups. Straight flush is the top. These are both straight flush. So that's 8, 7, 6, 5, 4, 3, 2, 1, and 0 at the bottom. So let's return 8 for the best possible type of hand. Okay, and then the next one is what? Now we want, so we did straight flush. Now we want a 4 of a kind. So if, now again we had that handy card count, of cards. If we find a 4 of a kind, if that's not none, we'll return a 7. That's the next one. The next one in our list is a full house. So we need a 3 of a kind and a 2 of a kind. So notice that our card count, it has to be exactly equal to that number. So it won't return. You have to have exactly 3 of a kind for card count of 3 to return a card value to you. So this one is going to be if the card count of cards with there's 3 values is not none, and the card count of cards with 2 values is not none. So there's both a pair and a 3 of a kind. Now we're going to return level 6. The next thing in our hands after the full house is a flush. That's easy. We already have that function. Now notice I'm not really worried about like absolute efficiency. We're calling a lot of functions multiple times. I've called this flush already. I could have saved that value and cached it or something, but we're really just out for readability and simplicity. So let's see if there's just a straight. Again, we can just call that same function we had before. If we have a straight high card of cards is not none, return a 4. And then I think after straight we have a 3 of a kind. Let's do that one. Again, it's just like our 4 of a kind. If the card count of cards of 3 cards is not none, return a 3. And now the next one, we're going to be looking at pairs. It's either 2 pairs or 1 pair. So let's get the value of the lowest valued pair we can find here. So we'll say pair 1 is card count of cards, exactly 2 cards. So if pair 1 is not none, okay, now we found exactly 1 pair so far. So now let's see if there's a second pair. So we do card count of cards of 2 cards, but we don't want to include the pair 1. And now we have 2 pairs, so that's our value 2. And if there isn't a second pair, then it's our card rank 1. And if all of these return return or don't none of those are apply, then we'll just return 0. All right, let's see that. Okay, I got a syntax error. I forgot a comma in somewhere. What is that? Cards of 3. Oh, it's way up here. I forgot a comma here. Let's see if that fixes that. It looks right. Let's test out the hand rank on our test set of test pans. Doesn't work. Let's see what I do. Let's see. Hand rank. Didn't like this. The card. Oh, is flush. I did id flush of cards instead of id of card instead of is flush of cards. So let's fix that typo. Ah, look at that. And I claimed that all my test cases were in order with nothing, high card ace only in the bottom, 1, 2, 1 pair, 2 pair, whatever, 3 of a kind, straight flush, full house, etc. All in order. So boom, there's our hand rank. So I think that's that's kind of the completion of this problem. And except for needing to then compare two hands against each other. How would I take two hands and compare them in this list? Let's see. So I will have let's compare hands. And let's just say we're going to compare just two hands against each other. I guess in general you might be comparing multiple hands if you have more than two players. But we'll get the hand rank of hand 1 and the hand rank of hand 2. And for a typical comparison function, you might return like -1 if the first one is smaller than the second one, 0 if they're equal, and 1 if the first one is greater than the second one. So we'll just say if R1 is less than R2, we'll return -1. If R1 is greater than R2, return 1, and otherwise we'll just return 0. So that is our compare hands function. It'd be nice to kind of test this out. So this is kind of I think this is the end of our function. I guess we could do something like compare hands of, let's do test hands of 3 against test hands of 4. So it should be -1, I think, here, because 3 is better than, or 3 is not as good as 4. 4 will always be better than 3 since we had them all in order. It was to reverse it, and we get a 1. If we compare any hand to itself, we'll get a 0. Okay, so I think this works, but I will maybe as a little bonus here, let's explore a little bit more things like the distribution of hands. Let's create a deck of cards, shuffle them up, and then deal some hands out, and then compare a bunch of maybe random hands, and so we can get some randomized test cases, and so we can just kind of look at that and convince ourselves that it's that beyond the initial test cases we thought of, that it works. So to start with that, I'm going to first make a deck of cards. So it's going to be an array of 52 cards, and I'll just make them in well-defined order. So there's a list of cards for each suit in diamonds, clubs, hearts, spades, and then for each value in the range of 2 to 14. So if the value is less than 11, we're going to create the part of the value string is just going to be the string value of the value, so a number from 2 to 10. Otherwise, we are going to choose one of our other special indicators, and it's going to be either a jack, a queen, a king, or an ace, with our value minus 11. So like the jack will be value 11, ace was value 14, and so 11 minus 11 is 0 to get the 0th element of this array. So the 11th, 12th, 13th, and 14th element of that array will be one of those things. So our value string is going to be that. And then our card will append to the deck the whole value string plus the suit at the end to the deck. And after we're done with that whole loop, we return the deck. a syntax error. I forgot the in. This is just a suit in this list. There we go. So let's make a deck and take a look at it. What does it look like? Boom. There it is. 2 of diamonds up through ace of diamonds. 2 of clubs up through ace of clubs, etc., etc., etc. Let's verify that we've got 52 cards in our deck. Go back here and say how many elements are in this. Length of our deck. 52. Okay, awesome. So now let's get a shuffle deck. A shuffle deck would be created by first making a deck. And then there's a really good, there's actually a shuffle. Let's see, if I imported random, no, I haven't gotten it yet. So let's, if you look in the Python manual for the random, let's see, how do I insert? I don't know how to insert in this. Okay, I think you hover over cell and you can say I want to add a code block. Let's import random. We're going to use this. So random.shuffle deck, and we'll return the deck. Okay, so now I say shuffle deck. What do we get? Hey, look at that. That looks pretty randomized. Okay, so that's it. So we have a shuffled deck now. And now we need to deal cards out of it. So let's make something that will deal whatever number of cards we want out of the deck. So we pass in a deck, and I say I want n cards out of it. We'll first get a hand, which is the first n elements of the list. And then we'll delete everything before the first n elements. I guess that's the same thing. We'll delete those elements from the deck and we'll return the hand. So let's say, so we started off this deck up here. Let's create a deck. Deck equals shuffled deck. Take a look at the deck. Begins with a king of clubs, and then let's get a deal out of the deck of 5 cards. Okay, we got the king of clubs through the queen of spades, which is right. And then if we took a look at what remains of the deck, let's see how many cards are left in our deck. 47. Yep. So we took off 5 cards off of that deck, and if we look at the deck itself, it begins with the ace of clubs, which was the one after the queen of spades. So yeah, that deal works. So now what I'd like to do is visually see a comparison of 2 random hands and have it print out some debugging information, or just so we can kind of easily look at any 2 randomly chosen hands and see what how they compare to each other. So I'm going to do a function that helps us out with that. Compares 2 hands. First, I'll use our function before to compare the 2 hands. All right, and then let's create a textual version of that, like the first one loses to the second one, or they tied, or beats the second one. and it's going to be sign plus 1. So we convert our -1, 0, 1 into a 0, 1, 0, 1, 2. So that'll be the result. And let's print that out. We'll use a format string of the first hand, and then the result, and the second hand. Okay. And let's also print the same thing out, except showing the actual rank of the, how we classified those things. Oh, and I'm going to add another. Let's get some classification names here. Let's see, let's add. There it is. Okay, let's add some names of cells. I have a little list here. I'm just going to copy this from my cheat sheet. Okay, so here's all of our rank names. So now, when we want to show how these hands compare, let's get the rank of the first one. So the hand rank of, it's a function, hand 1, and the hand rank of hand 2. And now we can print a formatted string with the rank names of R1, and then our comparison, and then the rank names of R2. Okay. So let's try this. So we have a shuffled deck already. Let's get 2 other hands. Let's get the hand 1 equals deal from our deck of 5 cards, and hand 2 is a deal from our deck of the next 5 cards. Okay, so we have hand 1, hand 2. There we go. And now show compare hands. Let's see, show compare hands. Hand 1, hand 2. All right, so it said in the first group there's a pair. I see a pair of aces. Yep. The second group is bupkis, and so it says that the pair beats the high card. There we go. Okay, cool. Another fun thing I think we could do is test a bunch of random hands, and so we'll just generate some test cases. Now that we have a way of generating random hands, and we can look at it, look at the results. So for I in range of n, we'll create a new deck. Every time we'll just get a fresh deck every time we make a test case. And we have hand 1. Actually, we can just do show compare hands of a deal from the deck of 5 cards with another deal from the deck of 5 cards. There we go. Let's try it. Test random hands. Oops. There we go. Let's see. A pair beats a high card. High card loses to a pair. Let's see, where's the pair here? Yeah, kings. And I don't see anything. Let's see, what's the best poker hand we got of this? Oh, here's a 3 of a kind. We have 9s on the right here, and here we have a pair. Pair of 7s loses to 9s. Nice. Okay. These are two tied. These are not actually tied, but as far as our algorithm is concerned, they're tied. It is ignoring what the high card value is. Pair, 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 high card. So we're getting a lot of pairs. We had a 3 of a kind, so that was kind of rare. But we still, I feel like we haven't seen like the full distribution of all the cards. It'd be just kind of interesting to see what is the distribution of, like, we've ranked all these cards now. We could use that to kind of compute the relative probability of all the different hands that we might deal at random. So let's create a big simulation. Let's deal like 100,000 hands to ourselves and rank them, and then take a histogram of all those things and see how many we get of each type of deck. So I'm going to rank distribution, and we'll by default do 100,000 different deals. So again, like before, we'll have a dictionary comprehension. We're going to start. We remember we had we had 0 to 8, so it's range 9. So that's going to be our initial distribution. So let's deal a bunch of cards here. This is not going to be particularly fast, but we'll create a shuffled deck. And then we'll get a hand from the deck, which is a deal from the deck of 5 cards. And then we'll increment the distribution for the rank of that. So the hand rank of that hand, we'll add 1 to that. So we're going to just count them all. And then after that, we will, let's print out what everything in our distribution. We could have returned the distribution here, and then have another function that prints it out prettily, but we'll just print it out here. So we'll do a format string with, again, we have that nice kind of rank names of the current rank, and then we will print the distribution. How many of those came out of that distribution, and it'd be nice to have kind of view that as a percentage. So let's do 100 times the distribution of R divided by N. So the total number of deals that we had, and that's a percentage. Okay, let's try it. Rank distribution. Let's try it with just 100 cards. And what did we got? Because I did the wrong. That's typo. Rank distribution. That doesn't look right. It's a bunch of zeros. What did I do wrong? Okay, when I added to the distribution, I meant to say plus equals to increment that. I just said plus, which did nothing at all. Let's try this again. Hey, there we go. So about 48% are just a high card, another 44% are a pair, 4% are 2 pair, 3% are 3 of a kind. We didn't get any straights. We got 1 flush, and of course none of these other ones. So we didn't get enough data to get all of the different distributions. And if we did this again, I think we get a different, we get a different random distribution. We got a full house that time, one time. So let's just amp up to the 100,000. Let's see if Google Colab will give you enough CPU to do 100,000 of these card shuffles without crapping out on me. Hey, nice. Okay. We didn't get any straight flushes, though, even in 100,000 hands. And if you go look at Wikipedia, you'll see there's only, it's like 64 or something out of 2 million. So 2 million possible poker hands. So we didn't get that many of them. But the other ones all look about right. We could try to run that one more time just to see if we get more. We get a few straight flushes. We should get maybe about 3 out of 100,000, I think, something like that. No, we got 1. We got 31 4 of a kinds, etc., etc. All right. I think that is it for this example. I hope you enjoyed that. And, you know, as a follow-on to this, if you want to make the compare function actually correct, let's see, then, where is it? Here. Down here, we need to put, we need to add test for high cards and tiebreakers. So it's pretty simple, I think, for some things. Like a tiebreaker for the flush would be what is the value of the high card, which could be equal. You have 2 identical straight flushes with the same high card value. 4 of a kind would just be the value of the 4. You don't care what the extra kicker is, because in a normal deck of cards, you're not going to have 2 identical 4s of a kind. The full house is going to be tiebreaker based on the 3 of a kind. Doesn't matter what the pair is, because you can't have 2 3s of a kinds of equal value. The flush, again, is going to be the high card. The straight will be, again, what is the high card of the straight? 3 of a kind will be the value of the card of the 3 of the straight. For 2 pair, you're going to have to actually compare both pairs to see if, you know, with the high pair is better than the other one's high pair. And if they're equal, then the low pair better than the other one's low pair. And if they're equal, use the kicker. So to figure out what that last value of that last hand would be. So, and similarly for the high card is just whatever well, you're going to have to go down the list of highest card to lowest card of each pair for that one. So it's a little bit tricky doing the following comparison, but I'll just leave that as a exercise to the reader. Okay, thanks a lot, and I hope you enjoyed that. Bye.